Hello. I'd like to thank Ozeki-sensei and the Tohoku Forum for Creativity for giving me an opportunity to be here today to talk to you about practical quantum computing. My name is Murray Tom. I'm the Vice President of Software and Cloud Services at WEB Systems. I've been in the field of quantum computing for 18 years, and in that time, I've had the opportunity to build quantum computers with my hands, to work with customers and share with them about what quantum computers are, what kind of problems that they solve, and help them to write their first software programs. And now to work on making quantum computers easier to use, to make access easier for everyone, providing open source tools, cloud access for services, as well as resources for learning how to program the systems and community forums for support. So I'm looking forward to sharing some of this with you, and also some of my excitement about the field and the opportunity ahead of us in terms of building real applications with quantum computers and seeing the economy and the opportunities that it creates. First, I'll say that at WEB Systems, we have a passion for building quantum computers for practical applications. There was a study done by 451 Research of Fortune 1000 companies that found that 4 out of 5 companies have a use case in mind for quantum computers in the next 3 years. And 2 out of 5 of those companies have already started getting going on building applications. I have seen the maturation of the quantum computing industry really come together so that today there are more than 20,000 developers who have access to the most connected and powerful quantum computers through LEAP, WEB's quantum cloud services and the quantum application environment there. There are professional services companies like Accenture who are tooling up teams of developers who are working with their customers to help them chart a course towards hybridizing their applications to combine quantum and classical resources together in order to accomplish their computational problems. And they're doing that because there is a drive and interest in business in order to be able to leverage this new and exciting technology. There are also major cloud providers. AWS Bracket, for instance, has provided access to WEB quantum computers, as well as others through their cloud services. And we've also seen entrepreneurs starting up their own businesses, learning about quantum computing and what its capabilities are, and building businesses around the technology. In fact, in many places, there are business incubators who are actually helping to bring entrepreneurs together with investors so that they can bring their creative ideas to market, like at the University of Toronto with the Creative Destruction Lab there. So what are quantum computers and what can they do? Let's get started on exploring this field. One thing I might mention is that there are lots of problems in the world where you're searching through a variety of different solutions in order to find one that's the optimum for a business application, something to do with looking through logistics and organizing activities or scheduling in order to make sure that materials or resources arrive just in time for the tasks that are needed. When approaching these problems with computers, you're often taking an intuitive understanding of a problem and then mapping it to a mathematical formula, which a computer can then work through that math formula in order to find its way towards higher quality solutions for you. It makes the landscape of possible solutions hilly, and it gives you an objective where, of all the possible solutions, the ones that are not as good can be created in a way where they're up on a mountain peak. They're hard to get to. You want to move off of those. And the high quality solutions you're looking for are down in the valley bottoms. Classical computers can approach problems of this type. And they do that by moving through the landscape step by step very quickly, working their way downhill in order to find their way to high quality solutions. They can do this incredibly quickly. They can maybe step through 5 billion points, solutions in the landscape every second. But the interesting thing is that even small problems with 300 variables, can create solution spaces that are larger than the estimated number of particles in the universe. And this is where the opportunity for leveraging quantum computing technology comes in. Quantum computers can put themselves into a state where they can actually delocalize their memory across every possible solution in the landscape. That's the exploration phase of a quantum annealer. And then it can gradually relocalize itself, bringing itself back to a single solution. And as it's doing that, it wants to move its likelihood off of the mountain peaks, just like water might, down into the valley bottoms, so that it's localizing on the highest quality solutions. This allows it to quickly and effectively find the lowest valley or valleys in that landscape, contributing to the creation of a solution to that problem. What's different about quantum computers than any other computer on the planet is that it is able to leverage quantum effects, effects like quantum entanglement or quantum superposition or tunneling, in order to accelerate its moves through the landscape on its way down to the low valleys to find the highest quality solutions, and to do that in a fast and efficient way. What's also fantastic about D-Wave's quantum computers is that you do not need to be a quantum physicist in order to learn how to program the systems and put them into application. In fact, it's one of the most sought after quantum algorithms for computation, which is that the problem that you pose to the quantum computer is a classical problem. And the answer that you get back is a classical answer. But the computer itself leverages quantum resources in order to obtain that answer for you, which means that you don't need to dive into controlling the superposition, the entanglement, the tunneling yourself, which I think many of you, like myself, would find that a relief. So where has the field of quantum computing been? Well, I would say that there was a period of about 20 years where quantum computing was the domain of researchers and scientists. They were building devices and studying quantum effects in order to learn how to put together components to make a computer that we can use in order to derive solutions and applications. 3 years ago, a group of researchers at Texas A&M and at NASA studied a set of problems where they were able to find a 100 times speed up over the best classical heuristics for solving these very challenging and difficult problems. And 2 years ago at D-Wave, we were able to publish work in material simulation in the journals of Science and Nature, which demonstrated how to apply D-Wave quantum computers and quantum annealers to the field of material simulation and study. And that work has actually been able to show that you can obtain up to 3 million times speedups over those best classical heuristics as you're solving problems. If those kinds of performance gains are available, that means that there are opportunities for major disruption in commercial operations and business logistics. And right now, there are businesses all over the world who are on the hunt for where in their business will this have an impact, and working on hybridizing their applications with quantum and classical resources in order to achieve a customer advantage, to see value in their businesses today. What's really important is that the approach that we are finding these users want to take is to not take their entire applications off of a classical computer and put it onto a quantum computer, but rather they want to find and use hybrid services that allow them to leverage quantum computers in their applications today and the quantum computers of tomorrow without having to disrupt or change their applications. And the benefit of that is that those future performance gains will be a lot less disruptive. It means that those applications will be future-proof, and users will be able to see the benefits of quantum computers accelerating their space as those technology developments are having in the field. It's a major transformation using hybrid solver services in order to be able to build and support practical business applications. So how do we do this? Well, you might be delighted to find out that you have access to quantum computers today. D-Wave Leap is the only real-time quantum cloud service, which allows you to submit problems to a quantum computer and get answers back in seconds, not later in the week or several hours from now. It includes access to the most connected and powerful quantum computers in the world today, the D-Wave Advantage systems. It's conveniently cloud-based so that you can grow or scale back the number of resources that you need as you're solving problems. depending on the conditions of your application. As you're programming and learning the system, you have real-time access. You can submit problems to the quantum computers and the hybrid solvers and get responses back in order to learn, tune, and develop your applications in a real-time environment. With user interfaces that give you easy access to an integrated developer environment, learning and programming resources, as well as a help center and a community forum for engaging with the other community of developers who are programming quantum computers today and for practical applications. So I think that all of the interesting aspects of quantum computers are sort of validated or made real when we think about, like, what can we do with quantum computers? What can actually be done? So this is an exciting application that Volkswagen pioneered at the WEB Summit in Lisbon in 2019. Here, they actually took the shuttle buses and they equipped them with iPads for the drivers, so that as the drivers were shuttling the conference attendees through the city, they could get real-time updated route information to optimize the overall route and to minimize congestion. This was done with a partnership of many organizations to gather that data, but in real time, queries were being made to our quantum computers and our hybrid solver services in Leap in order to be able to obtain route suggestions and updates to the routes the buses were taking in order to improve that experience. As complicated as it has been through my career to see quantum computers realized and built, it's so much more exciting to see them actually incorporated in an infrastructure which allows them to be used in practical applications that can affect our daily lives. Denso, which is a fantastic and major auto parts manufacturer, has been studying quantum computers and exploring their use in applications for some time. They have looked at techniques for optimizing the route of autonomously guided vehicles on factory floors in order to improve the productivity and the paths that those AGVs are taking. In fact, in an early study illustrated here, they found that even when they were optimizing for the safety of the AGVs to minimize collisions, they were able to map this problem to D-Wave quantum computers and see a 15% increase in efficiency. Since then, they have also incorporated very complex problem solving, looking at vehicle routing, just like this, in a scenario where there are multiple time windows where the vehicles need to be able to arrive at some stations or at different customers, and they need to meet those allowed time windows and not arrive at the wrong time. That significantly increases the complexity of the problem because it's including the time taken to travel and those extra constraints in solving problems. And using the hybrid solver services, they were able to solve problems of up to and over 44,000 variables for these practical applications. Recruit is a company that also got an early start in looking at evaluating quantum computers for practical applications. They actually observed a 1% sales uplift in their web services when looking at digital advertising and how they serve up information to their users. Now the company has actually been building toolkits which actually enable their engineers in different business sectors to be able to build up machine learning tools to find features and patterns within their data and improve their business operations that can leverage quantum computers. Toyota CRDL has also been looking at transportation-related problems, and particularly looking at the task of optimizing traffic signals in order to be able to improve overall flow. And in this study, they actually found that they were able to find better solutions using these mappings to these quantum computers because they're able to factor the traffic flow optimization across the whole network at once rather than trying to do this in small nodes. It's been a really encouraging study looking at improvements to how these applications can be run and leveraging these practical quantum resources that are available. GrooveNots, in collaboration with Mitsubishi, actually did a study to look at the optimization of waste collection vehicles in a particular area. And they found that they were able to reduce the distances that were traveled. And particularly this is impactful because it created an opportunity to reduce CO2 emissions in that regular activity that was happening all the time in our daily lives, reducing those emissions by 57%, and the number of vehicles required by 59%. Sigma I is a great company in Japan. I think many of you will be familiar with Tohoku, who have been studying and looking at a variety of interesting logistics and scheduling applications to really look at creating solutions that can impact our lives as they have all been affected by the COVID-19 pandemic. They've been studying areas of optimizing transportation of patients to medical centers in order to make sure that those patients are able to get there with minimum distances, but not overloading medical centers in particular areas. They've also looked at techniques for optimizing how diagnostic test strategies can be deployed in order to improve pandemic control. And they've also looked at software for allowing businesses and workers to be able to optimize a new normal. So as we're all working remotely and some of us are working back in our offices, there's a lot of scheduling and logistics that should be coordinated to make sure that we have the right resources in the right places who can communicate with one another so that we can still be productive in the economy and keep the economy going. It's fantastic to see the breadth and the variety of the applications that Sigma I has been able to build using hybrid quantum computing resources and demonstrate in order to bring practical applications to businesses that will positively affect us. Lastly, I want to share an example from a biomedical application with Menton AI. Menton AI is a company that has pioneered computational protein design. And what this means is that if you're going to use proteins for medical therapeutics, and you need to design them for new applications, you don't have to start with existing proteins and improve their design in the wet lab. But rather, you can actually start from scratch, designing a protein amino acid by amino acid in order to have one which is tailored to a particular application. And Menton AI has actually worked on integrating quantum hybrid computational resources in this problem solving, allowing them to solve some problems much faster than with their classical resources, but also, interestingly, finding protein designs that were otherwise not found using the usual approaches. And right now they have quantum designed proteins that have been validated through computational calculations. They have been synthesized and they're being applied to COVID-19 research in live virus testing in the wet lab. Very exciting research and really neat to see these applications and others for leveraging quantum computers practically in order to get us results today. So with this, with the access, the applications, there's actually a lot of room for users to get started right away using open source tools and begin programming. Let me tell you a little bit about the quantum computer that's available to you, the Advantage quantum computing system. It's the most connected and powerful quantum computer in the world, and it was built from the ground up for business applications in order to be able to use it to solve problems. This next generation of quantum computer involves an entirely new processor architecture. It's a complete departure from the quantum computers that D-Wave has supplied in the past. It's got 5,000 qubits, so significantly more processor size. It's going to allow larger chunks of application problems to be mapped to the quantum processor units themselves. And in addition to that, the qubits themselves are more highly interconnected with 2.5 times more interconnectivity, which also makes it easier for application problems to be mapped into the machine instructions that are sent to quantum computers in order to be able to obtain high quality solutions to very complex problems quickly. So that is the combination of resources that are available to you. An Advantage quantum computing system, it's the most powerful programmable quantum computer that's available on the planet. It's available for in-production applications at business scales, and it can support these through LEAP, the cloud service, which provides immediate access to these quantum computers and the 2000 Qs. It has an integrated developer environment to allow you to load software development kits and get programming right away. In fact, you can load different collections of examples to show you how to map problems to the system. And it will allow you to work at problems at a business scale, at a production scale like never before, enabling you to program up to 1 million variables in the system with these quantum hybrid solvers through LEAP. With that, I hope that I've been able to share some of the excitement about quantum computing and the opportunity for you to get started today. That involves identifying the right business problems and exploring what's possible, what's been already shown through hundreds of application examples to be suitable for mapping to quantum computers, and then to begin building hybrid quantum applications in LEAP right now. And you can do that by visiting our cloud platform at cloud.dwavesys.com. Once again, thank you so much for the opportunity to speak with you today at the Tohoku Forum for Creativity. I hope I've been able to share some exciting developments about quantum computing and also to interest you in the fact that you have access to these quantum computers today. And I hope also that through these practical examples, you can see, as I do, that what's really exciting about this technology is what you can do with it. Take care.